Okay, so let me start my today's lecture. We are continuing bulk metal forming processes, and till now we have covered. It is, I think, fourth lecture under module 3. Okay, so we have covered in under bulk metal forming. We have covered rolling. We are continuing with forging. Okay, so under forging, what we have covered 3.3. Okay, under forging, we have covered about a history, what is forging, and classification of forging we have covered. Okay, so this classification, under this classification, we have covered open die forging and impression die forging, which is also known as closed die forging. Then we have covered fleshless forging. Okay, so it is just to remind that these topics which we have covered. And under open die forging, as we already know, we have two flat surfaces, and your metal block is kept between these two flat surfaces of die. Okay, but in the case of impression die forging, okay, let me come to the diagrams. Okay, so this is your open die forging case. Okay, this is your closed die forging case. Under closed die forging, we have some, this metal block is being compressed between these two dies. Okay, one is sometimes called upper die. In some literature, you may find it is called as punch. Okay, and sometimes you may find only die, upper die and lower die. Okay, so under this, under these two, upper die and lower die, your metal block is kept. And kindly mute, someone is unmuted, kindly mute your mic. Okay, so these are two dies under which your metal block is being compressed. And certainly, since the material initial volume of your metal block is not exactly equal to your volume of your desired shape or final product, so there are some places extra surfaces over the extra material over the surface of your finished product, which is known as flash. Okay, so this is a undesirable thing, which is not desirable in the case of your forging processes. Okay, similarly, okay, so this obviously this flash, since it is undesirable, this has to be removed through certain method or certain process or certain procedure, which we will discuss in today's lecture. Okay, then we discussed third type of forging processes, which is called as flashless forging. Okay, so under flashless forging, what we are doing, we have a very the metal block or the initial block is kept in a confined space. Okay, in this confined space, what we are doing, we have punch, or you can say upper die, which is pressing your workpiece into the final product. Okay, so here the initial volume of your metal block is equal to your final volume of your or the finished volume of your finished product. Okay, so here a lot of calculations are required in order to do the calculation for the initial to calculate the initial volume, so that this volume is equal to the final volume of your finished product. Okay, so under this, normally this your die is this confined space where your metal block is kept, it is stationary, and punch forces the metal inside your die. Okay, so this way, here you can see there is no undesirable material over the surfaces of your finished product, so no flash is generated. Okay, that is why this process is called as flashless forging. Okay, so this we have discussed under open die forging. There are processes upsetting or upset forging. Okay, so under upset forging, we discussed that your product is kept between two flat surfaces, and there is reduction in height and increase in diameter. Okay, so this was the case of your under ideal condition when there is no friction, but in actual there is some friction. So the actual deformation is not which I saw earlier. The actual deformation is like this. Okay, so this circular generation of circular surface shape, it is called as barreling effect. Okay, so under actual open die forging process, there is barreling effect, and because of this barreling effect, the force requirement is slightly higher as compared to your ideal case. Okay, so these were the terms which we have discussed in previous lecture. Force equal to this kf is your shape factor. Okay, this we will continue. Okay, so then we discussed fullering, aging, and cogging. Okay, so this is your fullering, this aging, and this cogging. Okay, then under closed die forging, we have discussed advantages, operation, working principle, and then advantages, disadvantages. Okay, so flashless forging. Okay, so up to this we have discussed. There was one process under flashless forging. Okay, so coining, making of coins, it is done through which process? It is done through coining process. Okay, so that up to this we have discussed. If I think there is no confusion at all up to this point, and we will now move to forging hammer and presses. Okay, so forging hammers means these are the equipment which are used in forging machines. Okay, so these equipments are hammers or presses and forging die. These are the major equipment which are used in your forging process, and there are some other equipment which are also needed, like for heating your workpiece, you need furnace, and there is a need of mechanical devices for loading and unloading your workpiece. Okay, and also, as I told, in the case of other than flashless forging, because in flashless forging, no undesirable surface is there. But in the case of other processes like open die forging and closed die or impression die forging, there may be some undesirable surfaces or further machining may be required. Okay, so this is done on trimming station. Trimming means some extra material is being trimmed at these stations. Okay, so in the case of closed die forging, it is generally happens that there are some places over the surface of your final product, and these are trimmed from the surface of your final product. Okay, so under forging equipment, we have forging hammers, forging presses, and forging dies. Okay, so under forging hammer, what we have, these forging hammers are operated by applying an impact loading. Okay, so under these forging hammer, why these forging hammers are used? These are used to apply impact force. Okay, so what this impact force result? This impact force applies impact energy on your workpiece. Okay, so as soon as you apply impact energy, what happens? Your workpiece is converted into your final product. Okay, so how this is done? This is basically used in the case of closed die forging. Okay, okay. So the upper portion of the forging die is attached to the ram, and which is sometimes called as upper die or punch, and the lower portion is attached to the anvil. Okay, so or maybe sometimes called as lower die. Okay, so the workpiece is kept between the lower die and the ram is lifted and then dropped. Okay, so under forging hammer, what we are doing, we are lifting our punch or sometimes it is called as ramp. Okay, and this ramp is dropped from a certain height over your workpiece. Okay, so because of dropping, there is impact, and this impact energy, because of this impact energy, your metal block is deformed into your final product. Okay, so as the upper die strikes the work, the impact energy causes the part to assume the form of die cavity. Okay, why this is happening? This is happening because of the impact which is causing on the surface of your workpiece. Okay, so in some cases only one impact is sufficient, but in sometimes there are several impacts are needed. Several times we have to lift the ramp. Okay, and we have to drop again on your workpiece. Okay, so these each impact is called as blow. Okay, so there are several blows which are required uh, to achieve your final desired shape when we are using forging hammer. Okay, so these forging hammers are basically of two types. We can easily understand this, that gravity drop hammer. Okay, so and a gravity drop hammer means something which is being dropped against your gravity, or which is being dropping because of your weight of your you can say, since sponge is falling, you can say dropping of punch because of weight of punch. Okay, so under the gravity drop hammer, they achieve their energy by falling weight of a heavy ram, and the force of the blow is determined by the height of drop. Okay, so as much as height you have, the energy will be high. Okay, uh, and there is another type of drop hammer, that is the powered drop hammer. So under power drop hammer, the hammer, the forging hammer is accelerated using some external pressure, or this, which is maybe in the form of pressurized air or steam. Okay, so under power driven forge hammer, what we are doing, we are applying some power, some external power, as compared to gravity drop hammer. Okay, under gravity drop hammer, what was happening? The hammer was dropping because of its own weight. Okay, but in the case of power drop hammers, some extra power is also given to your hammer. Okay, so there are disadvantages of power driven hammer. Okay, so the one most important disadvantage is that the large amount of your impact energy is transmitted through the anvil into the floor of your building. Okay, so it is it can be easily understood that when some power driven drop hammer is being accelerated towards the anvil, okay, towards your workpiece, there is lot of energy loss, and there is lot of impact energy which is transmitted to the floor of your building where your machine is kept. Okay, so this is a diagram of your forging hammer, how these forging hammers looks. Okay, so here you can see this is your ram, and this is made up of a heavy heavy metal block. Okay, and this is connected to a piston rod. Okay, and this piston rod is connected to a some power unit which is used to transfer certain power which accelerate your ram, okay, or your piston rod. Okay, so this way your drop hammer or power driven gravity drop hammer or power driven drop hammer works. Okay, this is particular diagram is related to drop hammer. Okay, so here you can see the various components. Okay, so here this is your anvil where your workpiece is kept. Okay, so now there is another thing that is another equipment that is used that are used, forging presses. So sorry, forging presses. Okay, so under drop hammers, what we are doing, we are applying, force by an impact. Okay, so this impact may be, by the weight of your drop hammer, or some power is applied, and then it is called as power drop hammer. Okay, so in both the cases, we are what we are doing, we are applying impact on your workpiece. Okay, so the transition of your workpiece from raw material to final shape is, it's sudden. Okay, within within less than 1 second, the whole impact process is completed. But in the case of forging processes, what we are doing, the forging under forging processes, these presses, under forging presses, what is done, there is gradual pressure rather than sudden impact to accomplish your forging operation. Okay, so in order to complete the your forging operation, the gradual pressure is applied using your forging processes. Okay, so how what are the different forging processes that are used in forging industry? These are mechanical presses, hydraulic presses, and screw presses. Okay, so as the name indicate, mechanical presses convert the rotating motion of the drive motor into the translation motion of the ram. Okay, so these names are self-explanatory. Even if you remember these three names, mechanical presses, hydraulic presses, and screw presses, you can easily understand what are their function and how these are working. Okay, so under mechanical presses, we are converting the rotating motion of a drive motor into the translation motion of the ram. Okay, under hydraulic presses, what we are doing, these are hydraulically driven. It means these are being operated through some hydraulic power pack. Okay, where the hydraulic energy is used to drive the ram. Okay, then we have screw presses, and under screw presses, what is happening, we have a screw mechanism that drive your ram. Okay, so these are the this is all about your forging presses which are used in your forging industry. Now I will come to these. We have completed the major portion of your forging processes, and there are some other processes which are related to forging. Okay, so that I will discuss here, and after that I will close. Okay, so the first process, that is the upsetting and forging, the other related processes which are related to forging. The first one is upsetting and heading. So okay, so under upsetting, upsetting and heading. Okay, so this actually it means that heading operation is being done through upsetting. Okay, so as we discussed earlier, what is upsetting? Under upsetting, we are increasing the diameter and reducing the length of your workpiece. Okay, so under heading, what we are doing, we have some initial metal block. on which some head is being generated. Okay, so under where this heading operation is useful, it is used in fastener industry to form the heads on your nails, bolt, etc. Okay, so this creating head of your nail or bolt, it all comes under your heading operation. Okay, and it works on the principle of your upsetting. Okay, because what we are doing, we are increasing the diameter and reducing the length. Okay, so this process is quite often used in the steel, and the in bulk metal forming, I have already told that these may be at cold, hot, or warm, depending upon the requirement and requirement of requirement of machining. Okay, so during forging requirement, these may be performed at room temperature, or probably crystallization temperature, or some temperature at higher than your room temperature. Okay, so under heading operation, what is done? The long wire is fed into the machine, and the end of the stock is upset, forged, and then the piece is cut to the length to make the desired hardware item. Okay, so I think nails you have already seen in your daily routine life. You have okay. So this nail is having a certain head, and how this head is generated, this you can see here. Okay, so here you can see you have a wire stock. Okay, that is being and a head needs to be formed over this at one end of your wire. Okay, so this is your wire stock, and what we are doing, we have a stopper, and this is your feeder, and your what feeder is doing, feeder is feeding your wire stock towards your right side. Okay, from sorry, right to left. Okay, and then we have some stopper. Okay, so this is a stopper mechanism which is used to stop your feed wire or wire stock at a desirable position. Okay, and as soon as this feed wire stock is stopped, what we do, this stopper is kept away, and these two dies closes. Okay, so you can see there is gap here, but here in the second operation there is no gap. Your upper die and lower die are closed, and this wire stock is held rigidly between your upper die and lower die. Okay, so as since it is being hold held tightly between these upper die and closed die, this cannot move towards right if we are applying any force on the portion of your this left hand portion of your wire stock. Okay, so since this wire cannot move towards right, if we apply certain force at this end, what will happen, this will deform and exactly like upsetting operation. Okay, so under upsetting operation, we already know that the diameter is increasing. So as we apply forces, you can see at diagram 3, if you apply forces, what is happening, this is getting deformed in the exactly like upsetting operation. Okay, so this head, this is how the head are formed, and the final shape that is obtained, which you can see in diagram 4. Okay, figure 4. Okay, so here as soon as this upsetting is completed, using this arrangement, the head is generated over one side of your wire stock, and after this, what is done, these this this head, right hand side is cut at a desirable length, and this is how the process of making nail is completed. Okay, so as soon as this head is formed, we have a one cutter which is used to cut at this portion, okay, at a desirable location, and after that this nail is removed and the process continues. Okay, so this is how the upsetting operation is used in creating nails. Okay, similarly, this is another example where some other shapes may be created on your head. Okay, so here you can see some bolt is created. Uh, Here some uh, here we are using open die. Okay, so under open die is the nail is created like this. Okay, and some rounded shape is created. Okay, round shape head may also be created. Whatever shape we want, that is possible using the upsetting operation. Okay, but one thing is important: we have to keep hold our wire stock under two dies very tightly. Okay, this rigidly we have to hold this your wire stock. Okay, so depending upon the shape, here you can see the round head is formed. Here uh, uh, C and uh, some hexagonal bolt is formed. Okay, here some circular shape is generated. Okay, here also the combination of these two round and bolt. Okay, bolt head is generated. Okay, so this way these processes may be completed. Okay, or this upsetting of operation is used to create different kinds of head. Okay, now there are some other processes that is called swagging or radial forging. Okay, so under swagging, what we are doing under swagging, it is also a forging process which is used to reduce the diameter of a tube or solid rod. Okay, so what we are doing under swagging, we are reducing the external diameter of your tube or solid rod. Okay, so under swagging, what we do, there are slight difference between swagging and radial forging. These two processes looks like in terms of operation, but it's there is only slight difference that I will show. Okay, so under swagging process, uh, it is done by rotating the dies uh, that hammer a workpiece radially inward to taper it as the workpiece is fed into the die. Okay, so what kind of arrangement we have? Let me show first. We have this kind of arrangement, and your this is your starting diameter, and this is your final diameter. Okay, so under this under swagging, okay, or under radial forging, what we are doing, either your die is rotated or your workpiece is rotated. Okay, under swagging and forging. Okay, due to the rotation of this workpiece or die, the diameter of your initial product is reduced, and the reduced diameter is achieved, and there is certainly because of reduction in diameter, there is increase in length. Okay, so this way there is reduction in diameter of your your tube or your solid rod. Okay, and let me show here what is the difference between these two processes. Okay, so under radial forging, uh, uh, the difference is that the radial forging, the die do not rotate. Okay, so under swagging, what is happening, your die is rotating around your periphery of your workpiece. But in the case of radial forging, die is kept stationary and workpiece is rotating. Okay, any one of these is rotating. Either die is rotating or your workpiece is rotating. Okay, so in the case of swagging, your die is rotating. This diagram is basically showing your swagging process, which is used to reduce the diameter of your solid rod stump. Okay, or you can say tube. Okay, so under swagging operation, your die is rotating, but in the case of radial forging, this die is stationary and your workpiece is rotating. Okay, so this is a basic difference between radial forging and swagging. Okay, so these are the different components uh, which are produced using swagging operation, or you can say radial die forging. Okay, here you can see the reduction in diameter of a solid tube. Okay, then there is a tube. This was solid rod. Okay, this is tube. Okay, and this is another kind of operation that can be done using swagging. Okay, so here some groove is created on your tubular section. Then uh, there is pointing, how this pointing of a tube can be done. Okay, then swagging of neck on a gas cylinder. Okay, so how the this swagging is useful for making the neck of a your gas cylinder. So all this, these are the examples of swagging or radial forging. Okay, then we have one more process which is related to your forging, that is called as trimming. Okay, so trimming, uh, this I have already told in between while discussing your impression die forging or closed die forging, that while forging through impression die forging, there are some unwanted material on the surface of your final product, and which is known as flesh. Okay, so this unwanted material, since in terms of flesh, this needs to be removed. Okay, so how this is removed? This is removed through trimming operation. Okay, so in most cases, how this trimming is done? This trimming is done by shearing. Okay, so the shearing force is applied on the flesh, and it is removed from your finished product. Okay, and normally it is done at hot uh, and hot condition. Okay, and sometimes the flesh, fleshes are so rigidly attached, or the size of your flesh is sometimes quite high, so it cannot be removed by shearing process. Okay, so under those conditions, we have to adopt some other uh, other methods to trim out your fleshes from the surface of your workpiece. Okay, so there are other alternative methods which are used for trimming, such as we may go for grinding or stowing in the case of your for removing the extra material, that is flesh, from the surface of your uh, final product. Okay, so this is one diagram which is showing the how trimming is done. Okay, here you can see how this shearing process is being used to trim the extra places from the surface of your final product. Okay, so this is how your extra places are removed using shearing from your uh, final product. Okay, so this is all about forging, and I will stop here